I want to stop for a minute here and dwell a little bit more on the idea of angular velocity. I talked about the angular velocity as being a way to describe how fast a rotating object is spinning around. And that's all well and good for the world of physics. Angular velocity is normally how we describe the rate that something is spinning, but there are other methods that are much more common in everyday life and things that are much easier to measure. So I want to talk about those as well. So let's say you have a spinning object, like maybe I have this thing here, and it's spinning around in a circle, and it's spinning around in a circle at a certain rate. How would you describe the rate that the object is spinning around in a circle? Let's say that's the question. How would you, if you were watching that video or measuring that, and then you needed to tell someone how fast was that object spinning, how would you do it? Okay, so the physicist's way of doing it is the angular velocity, as we talked about in previous video. So the angular velocity, let me just say again, the symbol we use to represent it is omega. The units of angular velocity are radians per second. And by the way, as a side note, in this section of the course, we'll almost always be giving angles in radians for reasons that you'll see later. Degrees are not going to be so convenient anymore. So omega is radians of angle swept out per second. So in other words, what the angular velocity tells you conceptually is if you picture the object rotating around in a circle, as it's rotating around in a circle, you picture this angle here that the string is making with the horizontal direction, and that angle is growing, that angle theta is changing as the string goes around in a circle. How fast is that angle changing, irrespective of the actual properties of the circle itself? So how fast is the angular position changing? Okay, but you can see that there's a couple things not so convenient about that. That's the most convenient thing to use mathematically. But first of all, the units are radians per second, which, you know, is a little bit not that intuitive to kind of try to measure things in terms of radians. And then second of all, it talks about how this angle changes as the object is sweeping around in a circle. That angle is not necessarily so easy to measure in reality. So if you were literally doing this thing that I was describing, and I'm rotating this around and you had to describe this to someone, how would you even go about calculating the angular velocity? It would be really difficult to read off by eye. It would be difficult to measure in any way. And even if you did report like, oh, the angular velocity is 5 radians per second, what does that really mean to you? Probably not that much. So there are other methods of measuring how fast is something is spinning, which contains the same information, but are maybe a little bit more intuitive. So let me describe those as well. One of them is, why don't we start with the period of the object's motion. I'm sure you're familiar with this term, but I'm going to describe it anyway in our language. First of all, what variable are we going to use to represent the period in this class? And the answer is capital T. Don't ask me why. I guess it's T for time. That's what people like to use for the period. The unit of period is going to be, of course, seconds in SI. But I want to make a little bit of a point here. The SI unit for period is technically seconds, but really what we mean by seconds in this context is seconds per rotation. And that's going to be important later. And what the period tells you in words is how long does it take to make one rotation around the circle. Okay. Now that one's very self-explanatory. It's very easy to measure, and it's very convenient for things that are rotating slowly, like say the Earth. You know, the Earth rotates around the sun. The period of the Earth's rotation around the sun is 1 year. The Earth is also spinning on its own axis. The period of the Earth spinning on its axis is 1 day. So we naturally describe the Earth's motion using the period. We don't say, you know, oh, the angular velocity of the Earth's rotation around the sun is such and such, and that's how we track time. That would be rather confusing. We would rather say the period. There's another one that's extremely common as well. Number 3 is going to be the frequency of the rotation. The frequency, we use F to represent that. And the unit of frequency, so for what frequency, maybe I'll actually start with what frequency tells you. Frequency tells you how many times does it rotate per second. So like its rate of rotation. So for instance, in the example I was giving here, if you wanted to describe this, frequency would probably be the easiest way to do it. You could calculate like, you know, how many times does it go around in 1 minute, and then divide by 60. That would be how many times it goes around per second. Done, you know, and now you have a very easy to measure simple frequency of rotation. So the units of frequency in SI, what you're really measuring is the number of rotations per second. And the unit, we actually have a special name for this unit, and it's Hertz, HZ. And yes, that is the same Hertz that we use for computer processors. When you say a processor is like 1 gigahertz. In this case, it's not really rotations. Frequency is basically, in our case, rotations per second. In general, it's just the number of times that something happens per second. So like when we say a processor is 1 gigahertz, we're saying that inside that processor, things are happening at a rate of 1 billion times per second. And that's why it tells you how good the processor is, because it tells you how long does it take. Well, it tells you how many things are happening in that processor per second. So that's like how fast stuff's getting done. Okay. Now, you'll notice a few things here. First of all, you'll notice that the frequency is rotations per second. The period is seconds per rotation. So as you would probably guess from just looking at the units, the frequency and the period are inverses of each other. So if you want to know the period, just take 1 over the frequency. If you want to know the frequency, take 1 over the period. I'm sure algebraically you can see that this is true, but oops, that's the exact same equation. You can also cross multiply this equation and write it that way. So the period is 1 over the frequency is 1 over the period. In addition, both of these units are related to the angular velocity. And the reason why is because we know that just from simple geometry, that 2 pi radians is equal to 1 rotation. So you can actually think of that as being a unit conversion factor, and you can actually convert between omega, the angular velocity, and F, the frequency. So for example, let's say something is traveling at is spinning at a rate of, let's say, my example from earlier in the lecture. Let's say, well, let me be very careful about this. Let's say that you're given omega equals 5 radians per second. And let's say you want to know the frequency. How would you do that? Well, treat this as a unit conversion. So we have radians in the numerator. We want to get rid of that. So multiply by 2 pi radians divided by 1 rotation. Radian cancels out. And so you can see if you divide omega by 2 pi, then that's going to give you the frequency. So omega divided by 2 pi equals frequency. Or conversely, omega is 2 pi times the frequency, if you want to go the other way. So you can see that all three of these quantities are just related to each other by very, very simple equations. That's because all three of these are actually telling you exactly the same information. That's one thing I want to emphasize conceptually, is that the angular velocity, the period, and the frequency are all just three different ways of saying the exact same information. So it's not a new piece of information. If you're given the angular velocity and the frequency, that's actually not a new piece of information. That's actually just the same piece of information twice. The same way as if I told you, like, the object moved, 1 mile and it moved 5,280 feet. That is not two given pieces of information. That's just me giving you the same piece of information twice. It's the same way if I were to give you the angular velocity and the frequency, that's actually the same thing twice. And same with the period too, because the period is just 1 over the frequency. So that's the same thing again. So all three of these are telling you the same thing, which is how fast is the thing spinning. And you can state it in any of these three ways. You can also very, very quickly go back and forth between the three, depending upon what you want to have and what you are given.